I believe every specialisation requires a unique pedagogical approach, and mathematics is no exception. It's reasonable to assume that all teachers would hold this perspective about their own discipline. However, the extent of this uniqueness is subjective, and there will inevitably be some overlap in strategies and skills. Therefore, teaching mathematics requires specialised practices, but from my perspective, this does not imply that it exists in isolation from the rest of a student's curriculum. Mathematics is often seen as abstract or theoretical, and this perception is not unfounded. For example, consider the Pythagorean theorem. The formula of the square on the hypotenuse of a right angle triangle is equal in area to the sum of the square on the other two sides, and may be regarded as unintelligible or practically useless by some, letting it to either be inconceivable or forgotten. The unique challenge for maths teachers is to illustrate how this knowledge connects to real life scenarios, including areas such as construction, sports, art, and more. Maths instruction places a significantly greater burden than other specializations on linking theory with practical application, which aligns with a constructivist approach to learning. Arguably, this theoretical or cognitive learning is applicable across all STEM fields. It may be that other subjects, though, within STEM have modelled and applied these concepts more clearly than mathematics historically. The way maths has often been taught may have been too abstract, contributing to instructional differences. Since I have not yet had practical teaching experience, I find it most beneficial to reflect on my own experiences as a student to assess this question. Throughout most of my schooling, I would describe my relationship with maths as being characterized by mathematical anxiety. This experience is not unique, as shown by substantial resources devoted to addressing this issue, including efforts by the Victorian Department of Education. Mathematics anxiety not only undermines short-term performance by hindering engagement, but also poses a long-term issue by discouraging students from pursuing mathematics subjects, courses, and careers. Reflecting on my own experiences, I believe my mathematical anxiety stemmed from inadequate scaffolding during primary and junior secondary education. Without a solid understanding of early algebra concepts, I struggled to build the foundational knowledge necessary for tackling more advanced mathematics, such as calculus. Consequently, I had to largely self-teach this essential material after finishing school. From my perspective, scaffolding is the key for comprehending mathematics. Mathematical concepts are interrelated, with each idea building on previous ones to create a cumulative understanding, enabling progression to more advanced topics. This interconnectedness makes introductory knowledge essential for comprehending and solving complex mathematical problems. In my experience, these anxieties stemmed from the absence of these foundational concepts. The role of the teacher is therefore to demystify the subject, make it accessible and relatable, and address each student's unique learning style and anxieties. By focusing on these areas, teachers can help prevent students from falling behind and encourage continued study of mathematics into later secondary school.